In this video, we will look at timers as a possible cause for memory leaks and how we can detect them and possibly even fix them. Hi, I'm Rohan and this video is part of a series of videos where we are exploring how JS manages its memory in depth. More specifically, looking at various use cases that are the common causes for memory leaks and how we can understand and avoid these types of coding patterns. So let's get to it. Let's discuss how timers can cause memory leak. If you are a web developer, then you know that sometimes we need to perform some repetitive actions in our code. Like, for example, checking if an auth token is valid or not, or if we need to perform a specific action only once after some time, like logging out the user after an hour. So, timers have a specific and a very important purpose whether we like it or not. But use of setInterval and setTimeout, that is more often than not using an object, is the most common reason why that object is not collected by the garbage collector. So consequently, if we have a recurring timer, then the references to the objects in the callback will stay alive as long as there is a possibility that the callback may be called. Let's look at an example. In this example, we have a simple HTML file with an internal script. Within the script tag, we have a global array A and a function add items, which pushes a large array into A whenever it's called. After that, we have a set interval, which is calling add items every 100 milliseconds. Pretty simple, right? Let's open this in a browser. Open DevTools and go to the performance section. Record a few seconds of the page's performance. And we can quickly see that we have a problem just by looking at the net heap chart. Let's dig a little deeper and find out exactly what is causing this issue. So go to the memory section and select heap snapshot and click on the record icon. We wait a few seconds and then record a couple of more snapshots with a space of few seconds in between. Now notice how the snapshot size is rapidly increasing. If we click on one of the snapshots, we can see a list of objects that are being allocated. If we sort them by size, then we can quickly figure out which objects are taking a lot of space. Now, if we click on objects allocated between snapshots, then we can quickly list out those objects that have been allocated between the time that the two snapshots have been recorded. If we expand one, we can see that it's a big nested array. And look at the retained size. This tells us that we have a 2D array that is expanding rapidly over time, indicating a serious problem. So, how do we fix this? Let's go back to our code. The most obvious answer here is to limit the amount of times setInterval is being run. We first assign the interval ID that is being returned by setInterval to a variable. After that, let's pass it a parameter with count 100. In setInterval, instead of just passing add items as the callback, we instead pass an arrow function with a parameter params. We will add a condition that checks if params.count is less than or equal to 0. If it is, then we will clear the interval using the interval ID. Else, we will call add items and reduce params.count by 1. This limits the number of times setInterval will run the arrow function to 100 times. Let's open this in the browser tab, open DevTools and go to the performance section and record the first 20 seconds of this page. If we see the result, we can quickly see that in the first 10 seconds of the page, there is a sharp rise in the heap memory consumption. But after that, it's constant and it remains so. We need to understand this better. So let's go to the memory section. Refresh the page and record multiple heap snapshots, waiting a few seconds in between. We can clearly see that first few times the heap memory increased, but after that it remained constant in the rest. If we select the objects that are being allocated between the last two snapshots, then we can see that the list is empty, which means that while setInterval was running, the heap size was increasing rapidly, but as it stopped, the heap size became constant. This is because we still have a global object that is a big 2D array, which is preventing it from being garbage collected. Let's fix that too, since in our use case we can. So the first thing we do is remove the declaration of A at line number 10. Next, change the parameter object that we are passing into the setInterval to include a property A, which is an empty array. After that, pass params.a as an argument when calling add items. So consequently, we also need to add a new parameter a to add items. And then we save the changes. Let's open this in the browser. Then we open DevTools, go to the performance section and record the first 30 seconds of this page. Now, if you remember, in the previous code, the chart showed an increase in memory usage for the first 10 seconds approximately, but after that it stabilized. Let's compare this to our chart now. Now, if we look at the chart, we can see that there is a sharp increase in the memory consumption for the first few seconds. After that, it stabilized. So far, so good. After some time, the garbage collection process starts and the memory is cleared. So there is a sharp fall in the heap memory usage, which is what we wanted. Let's go to the memory section and record a few heap snapshots with a few seconds in between. If we notice, we will see that there is an increase in memory consumption, but then it declined to negligible amounts, indicating garbage collection. And if we click on objects that are being allocated between snapshots, one that is before the garbage collection and one that is after, then you can see that the big 2D array has been removed from the memory, which is a perfect solution for us. So, to quickly summarize, we looked at timers as a source of memory leaks using a couple of examples and how exactly we can fix them. In the upcoming video, we will look at event listeners as a potential source for memory leaks. If you have liked this video, consider liking and subscribing. Thank you for your time. Have a nice day. Namaskar.